Preparing for a GitLab Backend Engineer interview questions and answers interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design a scalable API for GitLab project in repository metadata? I would model projects, namespaces, repositories, and memberships as separate resources with stable identifiers. The API would support cursor pagination, filtering, sparse fields, and consistent error responses. Authorization must check project membership and protected resource rules, not merely authentication. I would index common queries, cache safe read-heavy metadata, and apply per-user or token rate limits. Versioning and deprecation headers protect clients. Metrics should expose latency, error rates, saturation, and expensive query patterns before they affect customers. While answering, focus on resource modeling, REST conventions, pagination, authentication, authorization, caching, rate limiting, backward compatibility, database indexing, and observability for a distributed, multi-tenant platform. Question 2. How would you prevent race conditions when two users update the same GitLab resource? For editable metadata, I prefer optimistic locking. Each record carries a version or updated timestamp, and an update succeeds only when the client's version still matches. A stale request receives a conflict, allowing the user to refresh or merge changes. For short, highly contended operations, a database row lock may be appropriate, but long locks reduce throughput. I would keep transactions small, make retries safe through idempotent keys, and test interleavings explicitly. Make sure to cover optimistic and pessimistic locking, transactions, version checks, conflict responses, idempotent, database isolation, retry behavior, and how user experience changes when concurrent updates cannot be merged safely. Question 3. What database strategies would you use to scale GitLab's PostgreSQL workload? I would begin with evidence, slow query logs, execution plans, lock statistics, and production-like benchmarks. Then I would add targeted indexes, eliminate n+1 queries, batch writes, and keep transactions short. Connection pooling protects PostgreSQL from excess clients, while replicas can serve carefully selected reads. Large tables may require partitioning, but that adds operational complexity. Migrations must be backward compatible, deployable in stages, and reversible where possible. Correctness comes before premature distribution. In your answer, talk about query plans, indexes, connection pooling, read replicas, partitioning, batching, avoiding n+1 queries, transaction boundaries, migrations, and measuring performance without compromising correctness. Question 4. How would you design an asynchronous job system for GitLab background work? I would place durable job records or messages in a queue, then use independently scalable workers for tasks such as notifications or repository processing. Every job needs an idempotent strategy because retries are inevitable. I would use bounded exponential backoff, classify permanent versus transient failures, and route poison jobs to a dead letter workflow. Queue depth, age, throughput, and failure rate reveal health. Workers should stop accepting new work during shutdown and finish or safely requeue active jobs. Be sure to mention queues, workers, retries, exponential backoff, dead letter handling, idempotent, visibility timeouts, prioritization, poison messages, monitoring, and graceful shutdown during deployments. Question 5. How would you design reliable webhook delivery for GitLab events? I would persist an event with its destination before attempting delivery, so transient outages do not lose notifications. A delivery worker sends signed payloads over TLS, records the response, and retries transient failures with capped exponential backoff. Recipients must treat events as at least once, so I would include an event identifier for deduplication. Strict timeouts prevent stuck workers. The product should expose attempt history, response codes, and a replay action while protecting secrets. Focus on durable event capture, delivery attempts, signatures, retries, exponential backoff, timeout limits, deduplication, ordering expectations, secret rotation, rate limiting, and customer visible delivery diagnostics. Question 6. Explain how you would secure a GitLab Backend API. I separate authentication from authorization. After validating a session or token, each request checks resource ownership, membership, role, and token scope. I would apply least privilege, validate and constrain inputs, use parameterized queries, protect against CSRF where applicable, and avoid exposing secrets in logs. TLS protects transport, while encrypted secret storage protects persistence. Audit events should capture sensitive actions. Rate limits and anomaly detection reduce abuse, and security tests run continuously in C. Cover authentication, authorization, least privilege, project and group boundaries, token scopes, input validation, secret handling, audit logging, rate limiting, encryption, dependency security, and defense against common web vulnerabilities. Question 7. How would you investigate a sudden increase in API latency at GitLab? I would first confirm scope using latency percentiles, error rate, traffic, and saturation by endpoint, region, and tenant. Traces can show whether time is spent in Rails, PostgreSQL, Redis, Gitaly, or an external service. I would correlate the start time with deployments, schema changes, traffic shifts, and queue growth. Immediate mitigation might be rollback, feature disablement, or capacity adjustment. After recovery, I would document the root cause, detection gap, and preventive action. In your answer, discuss golden signals, distributed tracing, recent deployments, database metrics, queue saturation, dependency failures, traffic changes, hypothesis-driven debugging, mitigation, rollback, and post-incident learning. Question 8. What caching approach would you choose for frequently accessed GitLab data? For read-heavy, recomputable data, I would use cache aside. Read Redis first, query the database on a miss, then populate with a bounded TTL. Keys should include resource identity, relevant version, and tenant boundaries. Writes must invalidate or version-affected entries, though stale data may be acceptable for some views. To prevent stampedes, use request coalescing or jittered expirations. I would define behavior when Redis fails, usually falling back safely rather than making it mandatory. Make sure to cover cache-aside behavior, key design, TTLs, invalidation, stale data, Redis failure modes, stampede prevention, serialization, tenant isolation, and when caching should be avoided. Question 9. How would you handle consistency between PostgreSQL records and Git repositories managed through Gitaly? I would avoid pretending PostgreSQL and repository storage share one transaction. First, I would define the source of truth for each field and record the intended operation durably. A worker can invoke Gitaly with an idempotency token, then update metadata and reconciliation state. If either side fails, retries or a repair job complete the workflow. Timeouts must distinguish unknown outcomes from definite failures. Periodic consistency checks and operational repair tools make eventual consistency observable and recoverable. Discuss transactional boundaries, source of truth decisions, asynchronous reconciliation, idempotent operations, failure recovery, consistency checks, timeouts, and why distributed transactions are usually avoided. Question 10. How would you design a safe database migration for a large GitLab installation? I would use expand and contract. First, add nullable columns or new structures without requiring a table rewrite, then deploy code that can read both representations and dual write if necessary. Backfill in small, throttled batches while monitoring locks, replication lag, and load. After all instances, use the new path, enforce constraints and remove obsolete fields in a later release. I would use feature flags, rehearse on production-sized data, and recognize that destructive changes are rarely instantly reversible. While answering, cover expand and contract deployment, backward-compatible schema changes, batching, lock avoidance, feature flags, migration monitoring, rollback limitations, and handling old and new application versions together. Question 11. How would you make a GitLab endpoint idempotent? For a side-effecting request, the client sends an idempotency key representing one logical operation. The server stores that key with the request fingerprint and final result inside a durable store. A repeated identical request returns the stored result. A reused key with different parameters is rejected. The record must be written atomically with the business change, or recovery becomes ambiguous. Keys need retention policies, and downstream jobs require their own deduplication because retries can cross service boundaries. Focus on operation identity, idempotency keys, persistence of results, duplicate detection, retry semantics, transaction boundaries, expiration, and differences between safe reads, updates, and side-effecting requests. Question 12. How would you test a backend feature before releasing it at GitLab? I would start with focused unit tests for business rules, then integration tests covering PostgreSQL, Redis, queues, and Gitaly boundaries. Contract tests protect API consumers, while a small number of end-to-end tests validate critical workflows. I would add authorization, migration, concurrency, timeout, retry, and performance cases based on risk. Tests should be deterministic and run quickly in merge pipelines. A gradual rollout with metrics and logs validates behavior under real traffic without hiding failures. In your answer, include unit, integration, contract, end-to-end, security, migration, performance, failure path, and concurrency testing, along with isolated tests and meaningful observability in production. Question 13. How would you design authorization for nested GitLab groups and projects? I would represent namespaces, groups, projects, memberships, and roles explicitly, then calculate effective permissions from inherited and direct grants. The decision must account for protected branches, deployment environments, token scopes, and user state. Authorization defaults to deny with shared policy code rather than endpoint-specific guesses. Cached decisions require short lifetimes or versioned invalidation after membership changes. I would test inheritance, revocation, cross-project access, and malformed identifiers specifically because leakage is more serious than ordinary failure. Be sure to mention inheritance, explicit membership, role hierarchy, protected resources, token scopes, authorization caching, revocation, deny by default behavior, and tests for cross-tenant data leakage. Question 14. How would you process a large repository operation without blocking web requests? The request should validate permissions and create an operation record, then enqueue work and return a status URL. A worker performs the repository operation with CPU, memory, disk, and execution time limits. Progress events or polling provide feedback, while cancellation marks the job and lets the worker stop at safe checkpoints. Authorization should be rechecked when work begins. I would isolate temporary files, avoid loading large objects into memory, and throttle concurrency so Gitaly remains healthy. Discuss asynchronous execution, job progress, cancellation, resource limits, streaming, temporary storage, user visible status, authorization at execution time, retries, and protecting shared repository services. Question 15. How would you approach a backward-compatible API change in GitLab? I would prefer an additive change. Introduce a new optional field or endpoint while preserving existing response shapes and semantics. Consumers should tolerate unknown fields, and servers should accept compatible requests during migration. If behavior must change, I would use explicit versioning or a feature flag, publish deprecation timelines, and measure usage through telemetry. Contract tests identify dependent clients. Removal comes only after communication, migration support, and evidence that the old interface is no longer active. Cover additive changes, tolerant readers, versioning, deprecation communication, schema evolution, client compatibility, feature flags, contract tests, telemetry, and a measured removal process. Question 16. How would you prevent N+1 queries in a Rails-based GitLab backend? I would detect N+1 behavior through development query logs, tracing, and query count assertions around endpoints. Then I would preload associations when the access pattern is known, choosing joins only when filtering or sorting requires SQL participation. Batch loaders help when relationships vary dynamically. Serializers should request only needed fields, and pagination limits result size. I would verify that eager loading does not create huge joins or bypass authorization. The goal is fewer queries without replacing one inefficiency with memory pressure. In your answer, mention query logging, eager loading, preload versus joins, batching, serializers, authorization-aware associations, query count tests, pagination, and avoiding excessive object hydration. Question 17. How would you design rate limiting for GitLab APIs and expensive repository operations? I would combine per user, token, IP, and project limits, because each catches a different abuse pattern. A token bucket algorithm permits short bursts while enforcing a sustained rate. Expensive repository operations should consume more quota than metadata reads. Distributed counters require atomic Redis operations and clear expiration. Responses should include retry guidance and limit headers. I would distinguish trusted internal traffic carefully, monitor false positives, and choose fail open or fail closed behavior based on endpoint risk. Focus on identity dimensions, token buckets, distributed counters, burst handling, endpoint cost, trusted automation, response headers, fairness, abuse prevention, and behavior during Redis or limiter failure. Question 18. How would you use feature flags to release a risky backend change? I would introduce the flag only after the old and new database paths are compatible. It should default safely, support internal users or small percentage rollouts, and expose metrics segmented by flag state. A kill switch provides rapid mitigation without redeployment. I would document the owner, expiration date, and rollback behavior, then remove the flag after adoption stabilizes. Flags are operational tools, not permanent architecture. Lingering branches increase test burden and create inconsistent behavior. Make sure to cover default safety, targeting, gradual rollout, database compatibility, observability, kill switches, flag ownership, cleanup, and avoiding divergent code paths that become permanent. Question 19. Describe how you would handle a partial failure in a multi-step backend workflow. I would model the workflow as durable states rather than relying on one request thread. Each transition records intent and outcome, and workers retry transient failures idempotently. If a later step fails, a compensating action may undo earlier effects, or the system can expose a recoverable pending state. Timeouts need reconciliation because the remote operation may have succeeded despite an absent response. I prefer explicit orchestration for complex workflows because ownership, observability, and recovery paths remain clear. Discuss durable state machines, compensating actions, retries, idempotency, timeouts, unknown outcomes, reconciliation, user visible status, and choosing orchestration versus choreography for workflow clarity. Question 20. How would you demonstrate GitLab's values while resolving disagreement in a backend design review? I would write the problem, constraints, alternatives, risks, and measurable success criteria before the review, which supports GitLab's remote and asynchronous culture. During discussion, I would separate evidence from preference, invite concerns from quieter participants, and focus on user impact and operational cost. If disagreement remains, I would propose a small experiment or ask the responsible decision-maker to choose. Once decided, I would commit professionally, document the rationale, and revisit it only when new evidence justifies change. In your answer, emphasize collaboration, written proposals, data-driven trade-offs, asynchronous communication, direct but respectful feedback, user impact, maintainability, experimentation, and committing after a decision. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.